Well, okay, welcome to part two of our video on how we can use parabolas and quadratics in real life. So in part one, we saw how we can use the vertex form of a parabola to find out certain things like how high the parabola is and to kind of get an equation. We also learned that there's a really quick, easy way of finding the vertex, the x value of the vertex of any parabola, and that's using part of the quadratic formula. The negative b over 2a part, which you can see right here, helps us find that vertex. So we left off talking about the cannon problem, but we didn't start it. So the first question with the cannon problem is to find the maximum height attained by the ball. So remember, we have, let's see if we can put this into like a picture on the coordinate plane. We have right here, starting up a little bit above ground there, we have a cannon, and it shoots a ball, and that ball, of course, we know follows this parabolic path before, boom, it hits the ground. And, you know, there's kind of this, if we finish the parabola, there'd be this like little kind of imaginary arc here to the left, but that's negative time. That obviously it starts above ground. So if we allowed for negative time, technically the parabola would hit the ground back here. But what we're looking for is the maximum height of the ball. And that maximum height is going to occur right there at the vertex. I'm just going to put a V because I can't write on this mouse. So to find the maximum height, what I want to do is I first want to find the coordinates of this vertex. So we know that we can find the vertex, the x values, using negative b over 2a. Well, in this case, you can see b is right here. It's 48. And we have a is negative 16. Now, I said the x value. I guess I should go back and say t is the x value in this case. It's time. And h is the y value. We used h and t because they're meaningful in this case. They stand for the height and time. So using my calculator and figuring out what t is, I get t is about 1.5. So I know that in about 1.5 seconds, this cannonball is going to hit the peak. It's going to hit the vertex. And that's how many seconds have elapsed. But let's go back and look at this question. The question doesn't ask in how many seconds will the maximum height be attained. It says what is the maximum height. And so in that case, we're looking for this y value, or in the context of this problem, the height, the h value. So how do I find that h value? Well, gosh, I have this lovely little recipe right here. It says you can find the h value if you know the t value. And I know the t value, it's 1.5. So I'm going to take that recipe right there, that recipe for height, and I'm going to plug in this 1.5 everywhere there should be a t. And then using my calculator, I can find that maximum height is going to be 37.5 feet. So again, we have this whole idea that when things are thrown, when things travel through the air, they travel in this parabolic path. And these values we've been finding algebraically, these graphing values like the vertex and the roots, they have meaning in real world contexts. As a matter of fact, there are a couple other questions that follow up with this, like question 4. Same scenario, same equation, but question 4 says, how many seconds did it take for that cannonball to land? And again, if we come back over here and we think about what's going on graphically with this scenario, we have a cannonball leaving here at about 1.5 feet above the ground. It travels in this parabolic path, and then boom, it hits the ground. So how do we find when it hits the ground? Well, we're not looking for a vertex here. We're looking for a root. And when you think about this equation up here, what we're looking for is when the height of this cannonball is 0. So what we're going to have to do to solve this problem is set the height equal to 0 and solve this. And when we solve it, we're going to get a value for t. Well, actually, we're going to get two values for t. And when we solve it, one of those values for t will be positive. The other value of t will be negative because, again, if we imagine completing this parabolic path, the other root would happen here at negative time, which of course is silly. How are you going to solve this? Well, I would imagine you could try to factor that, but it's not going to factor. You're going to have to use the quadratic formula. And that's something I'm going to let you do on your own, well, with your partner today. And then finally, the last question, same problem, same scenario, but this time it says, how long did it take the cannonball to reach a height of 20 feet? Well, we know from earlier that the maximum height that we got was 30, I think this was 37 feet. So we know it's going to hit 20 feet for sure. As a matter of fact, won't it hit 20 feet two different times? One time going up and one time going down? Well, when we get to this problem here, we need to know when the height is 20. Well, come back and look at that equation. We're not talking about a time, we're talking about a height. So if I replace this with 20, and I solve this by moving the 20 to the other side and using the quadratic formula, I should be able to get the value of t, actually the values of t, when the height is 20. So again, that's something I'm going to trust you and your partner to do working together.